All right, so for number 19, we have a function, and we have to find certain things for it. So on part A, we have to find the horizontal and vertical asymptotes. So first, let's try and simplify this function if we can, because we can see that this can be factored, right? This can be factored into, we'll have x plus 8 at the top, but it can be factored into x plus 8 times x minus 2, which will then simplify our function, because those x plus 8's cancel, so we just have 1 over x minus 2. And so since we have 1 over x minus 2, that means we can, to find our vertical asymptote, we can set the denominator equal to 0 and solve. And so if we do that, that'll be x minus 2 equals 0, or x equals 2, which means we'll have a vertical asymptote at x equals 2. And then we know that we can't have we can't ever get 0 for our function. And so we know that we're going to have a horizontal asymptote at y equals 0, since, the power of the x on the bottom is greater than the power of x on top. And so horizontal asymptote at y equals 0. And then for part B, it says to determine whether there are any holes in the graph. So we just said before that we can kind of cross these x plus 8's out, right? But that doesn't get rid of them completely. We have to, that means we have a hole there, right, since we crossed them out. And so what we can do is we say, okay, so at x plus 8 equals 0, or x equals negative 8, we're going to have a hole. And so then we can plug that negative 8 into our simplified function of 1 over x minus 2. So then it's going to be 1 over negative 8 minus 2 equals negative 1/10. And so then we're going to have a hole at negative 8 as our x point, and then our y point, which we said was negative 1/10. And so from this, we can determine our domain. And so we have, remember, that vertical asymptote at 2, so we can't have anything at 2. And then we also have that hole at negative 8, so we can't have any x value at negative 8. And so that means our domain is going to go from negative infinity to negative 8. We got to stop there. And then we'll pick back up at negative 8 and go until we hit 2. My bad. Until we hit 2. And then go from 2 to infinity. And it asks to make a rough sketch of the graph. And so, like I said, we know we're going to have a vertical asymptote at 2, and then a horizontal asymptote at 0, and then a hole at negative 8, negative 1/10. And so we know our behavior is going to look a little bit like this. If we plot some points, we'll be able to see that our behavior kind of looks like this, which isn't super connected, but there we go, kind of like that. All right, so for number 20, we have an angle has its vertex centered at the origin of a circle. It cuts an arc length of 54 centimeters and subtends a sector with area 324 centimeters squared. And so we have to find the radius and the angle. And so first, we can use the information of it cuts an arc length of 54 centimeters, because we know that arc length is equal to the radius times the angle that we're making. So in this case, we'll have 54, looks like an S, but 54 is equal to r times theta, right? Or if we solve for theta, that's going to be theta equals 54 over r. And then we know the area for a circle. Okay, so we know the area for a circle is usually pi times r squared, right? But in this case, we're going to have an added theta over 2 pi, because it's not the whole circle, right? If we had the whole circle, the angle of the whole circle, it makes this 2 pi. So if we had like a theta equals 2 pi, that would mean it's the whole circle, and so we'd just be left with pi r squared. But since this is just a portion of the circle, this is going to be times a theta over 2 pi, where theta is in radians. And so then that pi cancels out, and we're just left with 1/2 r squared theta. And so then we can plug in for our theta that we came up with. So then that's going to be our area, or our 324, is equal to 1/2 r squared times 54 over r. And so then if we solve for r from there, we'll get an r is equal to 12 centimeters. And so then we can use that information in part B to find our actual angle. So we can just use, well, that relation that we came up with here. So we're going to have theta is equal to 54 centimeters over 12 centimeters. And so that's going to give us 4.5, but that's in radians, right? In terms of the arc length equation. And so if we convert that to degrees, so we'll have 4.5 radians. And then to do for degrees, we just do 180 degree per pi radians. And so then we get 257.8 degrees.
Okay, so for question 21, we're looking to name an angle that is coterminal to negative 11 pi over 9 that lies within the interval 0 to 2 pi. We want to name the quadrant that it lies in and its reference angle in radians. So I guess my first thing that I'm going to do is I'm going to go ahead and get these to the same denominator as what we were given, or the same numerator, sorry. So knowing that we have something over 9, I'm going to write this as I'm going to leave it as 0 and 18 pi over 9, just so it's easier for us to see when we are within that interval. So I guess to start, I'm going to say negative 11 pi over 9 plus 2 pi, which is the same as negative 11 pi over 9 plus 18 pi over 9. It's going to yield 7 pi over 9. So that is between 0 and 18 pi over 9, so we're good there. So that's our angle. Thinking about it on the unit circle, though, now 7 pi over 9 is going to be greater than pi over 2, just because 7 over 9 is greater than 1/2. So it's going to be past here. It's also less than 1. So I'm going to say it's between pi and pi over 2, which places it in the second quadrant. And it's going to be kind of over here, thereabout. Now, this whole thing, obviously, this whole big angle is pi. So I know in order to find this reference angle, I can say that angle theta is equal to the whole thing minus our 7 pi over 9. And that gives a reference angle. So we have our given angle here. We know it's in quadrant 2, and reference angle 2 pi over 9. Perfect. Moving on to question number 22, we're given that tangent theta is equal to 5 pi over 2. Because tangent is positive, that means that our angle is going to be within the first quadrant or the third quadrant. And cosine theta is less than 0, which only happens in quadrant 2 or quadrant 3. And remember, that's just because cosine of theta, or cosine is like our x value. X is only less than 0 in these two quadrants. So I guess by process of elimination, we know that our angle is in quadrant 3. So just moving on from there, we know that tangent theta is our opposite over adjacent, right? So what I'm going to do is I'm going to say, okay, let's construct a triangle over here where this is our theta. Our opposite is going to be a -5. And then that means that our adjacent is going to be a -2. Now we need to find the value of this side, or the length of this side, which we're just going to use the Pythagorean theorem to solve for. Skipping ahead, we can show that c squared is 29, or just that length is equal to root 29. So now looking back at our triangle, we have all the three sides of our angle, or all three sides, and our angle here, theta. So now thinking about what our value of cosine is going to be, that's going to be our adjacent over hypotenuse. Be adjacent over hypotenuse, which means that cosine of theta is going to be -2 over root 29. Then looking at, excuse me, sine, that's opposite over hypotenuse. So that is going to give us a value of -5 over root 29. Perfect. And now finally, on number 23, we're looking for t is an acute angle such that sine of t is this for a positive number x. We want to find all of the remaining 5 trig functions just in terms of x, right? So what I'm going to say first is sine, I'm going to write down what we were given, that sine of 5t is 5 minus x over 5 plus x. It's going to be our opposite over hypotenuse, right? So I'm going to go ahead and kind of label an angle, or label a, label a triangle. We know it's acute, so it should be in quadrant 1. We know that the opposite side is 5 minus x, hypotenuse is 5 plus x. Then this side, we're going to use the Pythagorean theorem again. Squared plus b squared equals c squared. We're wanting to solve for one of the sides, so I'm going to use b squared equals c squared minus a squared, where b squared is 5 plus x squared minus 5 minus x squared. Going out and foiling all that is going to give us b squared is equal to 25 plus 10x plus x squared minus 25 minus 10x plus x squared. X squareds are going to go away, 25s are going to go away, to give b squared is equal to 20x, or just b is equal to square root of 20x. And that is going to be this side here. Breaking down that radical a little bit more, we can just go ahead and say that's going to be 2 times the square root of 5x, just because 4 is a factor of 20. So now moving on to cosine, or moving on to actually figuring out our trig functions, we know that cosine of the angle is it's going to be adjacent over hypotenuse. Our adjacent side is 2 root of 5x. Our hypotenuse is 5 plus x. So that's going to be our cosine. Tangent is opposite over adjacent, which will give us 5 minus x is the opposite over 2 square roots of 5x as the adjacent. Cosecant is 1 over sine theta, or hypotenuse over the opposite, which will give us 5 plus x over 5 minus x. Secant is 1 over cosine, or hypotenuse over adjacent, which will yield 5 plus x as the hypotenuse, over 2 root 5x. And then cotangent is 1 over tangent, or adjacent over opposite, and that will give us 2 square roots of 5x over 5 minus x. And also, I think it's important to notice that cosine and secant are reciprocals of each other, as are tangent and cotangent, and then finally cosecant and sine. And that's just how putting something over 1 works. So, perfect. Moving on to question 24, we are given that Cassie measures the angle of elevation from the ground to the top of a pyramid to be 28 degrees here. If the pyramid is 300 feet tall and the angle from elevation of its sides is 40 degrees, we're asked to determine how far away Cassie is standing from the pyramid. So in order to do this, we're going to have to do a little bit of fancy trigonometry, but I guess our first goal is going to be determining this distance, and then determining this distance, and from there we can find x. So I'm just going to label this distance from Cassie to, I guess, the center of the pyramid, or the top in horizontally as A, and then the distance from the edge to the top horizontally as B. So now constructing our triangle using A, we're given that this is A, we have a height of 300 feet, and we're given this angle of 28 degrees. So knowing that tangent relates to the opposite and the adjacent side, I'm going to go ahead and say tangent of 28 is equal to 300 feet over A, and it's 28 degrees, which means that A is going to be equal to 300 feet over the tangent of 28 degrees. And that is going to give us a value of 546 2.22 feet. Now, constructing our other triangle, we're given pretty similar information. We know that the top is still 300 feet. Now, this is instead going to be 40 degrees, and we want to find this distance. So, using the same method, we're going to say tangent of 40 degrees is equal to 300 feet over B, or just B equals 300 feet divided by the tangent of 40 degrees, which will give us a value of 357.53 feet. And then subtracting these two values is going to give us that, I guess, this distance here, x, is A minus B, or 546.22 minus 357.53, or that x is 207 feet, just because, again, we are wanting to round to the nearest foot. So this is going to be our distance that Cass sees from the pyramid. Perfect. And now moving on to section 7.1, we're looking at graphs of sine and cosine. So this graph is representing the high and low temperature of a summer day. The temperature throughout the day is modeled by a sine or cosine graph, where y represents the temperature in degrees and t represents the hours after 3 a.m. So we're doing each of the following. So my first thing I'm going to kind of look at here is that I'm going to use a cosine function in part A, because if you notice, here we're starting at the very bottom of the curve. Sine would start around here. So I'm going to start with cosine just because that gets us to start at the bottom. Now, because of that, we don't have any left or right shift, so we're all good there. And then as far as the amplitude goes, our minimum value here is 69, and our maximum value here is 103. 103. Which means that our amplitude is going to be half the distance between those two. So that's going to be 1/2 of 103 minus 69, which is going to be 117. Just 17. Just 17. Now, onto the period. I'm going to look at the bottom and see when we repeat that again. It's going to be over here. If we look, that has an x value of 24. So our period is 24. And then next, our midline is going to be half the distance between the top and the bottom. So that'll just be 69 plus 17, or we could write it as 103 minus 17. Either way, we're going to have 86 as our midline. And then moving on to part B, I'm going to start with our function in terms of cosine, because that's what we were thinking of that's what we had in mind for ours. And I'm going to, I guess, just start writing in this form. So first of all, we know our amplitude is 17. We're using cosine. Now B is going to have to do with our, I guess B is related to the period by this equation here. So we could say, okay, well, B is 2 pi divided by the period, which is 2 pi over 12. Sorry, 2 pi over 24, which is just pi over 12. So we're going to have 17 cosine of pi over 12. T, because we don't have any horizontal shift. And then we're shifting up 86. And then one last thing we have to fix is that this graph that we just wrote would start at the top of the curve, but our actual function starts at the bottom. So we're going to have to make that negative just to flip it and get it to start on the bottom like it does here in our graph. Moving on to sine. Now to get our sine curve, we're going to have to shift this whole function over. We're going to have to think of it as shifting the function, having the function here shifted over by 6, right? So this is where we would start if it was a sine function. We've shifted it to the right by 6 now. So almost everything is going to be the same, except we can use 17 as a this time because it should, sine is rising here, just like it would be if we just had sine over x, which starts at here, kind of is rising through the 0. So we're good to use 17 as our a. We have sine of pi over 12, t minus 6, again, just because that's our horizontal shift. And then it's going up 86. So that is going to be our k. That is it for part 3. Just stay tuned and we'll have part 4 out soon. Thank you for watching.